Okay, so we're going to use Mr. Waterman's old split, flip, and rat technique to write down the continued fraction for the square root of 2. So first we have to split the square root of 2 into an integer part and a non-integer part. Does anybody know approximately what the square root of 2 is?
It's 1.414.
Okay.
1 4.
1 point, not 1 plus, 1.414, dot, 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 dot. So what's the integer part?
1.
1 plus
0.414.
0.414, etc. And how can we write this 0.414, etc. as a number that has the square root in it, that has the square root of 2 in it? So this is
It's
1
the square
plus,
root of 2 minus 1.
very good, square root of 2 minus 1. So the first part of our continued fraction is going to be this 1. Okay. Now we have to flip this. What does that mean?
Does it mean like flip it to become
Take
like
the reciprocal?
Well, but we want it to be equal to the same thing. This is the interesting little trick, and involves a little bit of dividing by fractions. So what fraction, if I had, let's go back to here. If I have the number 2, what fraction equals 2?
It's 2 over 1.
2 over 1. That's good. That's a fraction that equals
Or
2.
1 over 1/2.
1 over 1/2. High five. That's the flip. We're going to flip down to the bottom and put the reciprocal of our number on the bottom. Okay. So this is 1 plus 1 over the square root of 2 minus 1.
Now I can see the continued fraction starting to appear.
Yes, you can. There's 1 plus 1 over. Now, how do we rationalize? This, I think, is something that you've probably never seen before, except in some old movies. You might know how to do this. How do I rationalize this? How do I get the square root of 2 minus 1 in this fraction on the bottom, but in a different form?
Well, you have to get it onto the top.
Okay.
You have to rationalize it. So if we multiply by the square root of 2 plus 1...
Aha! That's going to create a difference of squares.
Yeah.
And it's going to get rid of the square root of 2. So this now equals, the whole way around, these have all been equal, right?
Yeah.
This is, square root of 2 minus 1 is equal to 1 over the square root of 2 minus 1. So I get 1 plus 1 over, I multiply by the square root of 2 plus 1, and the square root of 2 plus 1. Now, what is the square root of 2 minus 1 times the square root of 2 plus 1?
I think that, wouldn't it be the square root of 2? It wouldn't be the square root of 2.
Well, no, it would be 2. The square root of 2 times square root of 2.
Yeah?
Plus square root of 2.
Yeah.
Square root of 2 times 1. Minus square root of 2. Minus 1 times square root of 2.
Uh-huh.
And
And then minus 1.
So what do I get left with?
you get
We get 2 minus 1.
Which is?
1.
1. So I get 1 left on the bottom. And what do I get when I multiply 1 times the square root of 2 plus 1
you
on the
get
top?
it's just the square root of 2 plus 1.
That's my rat. So split, flip,
And rat.
and rat.
And then you can split the square root of 2 again.
Right, now I'm back to the split. Now I don't have the square root of 2, I have the square root of 2 plus 1. So what's the integer part of that?
It's
just
2.
Why is it 2?
Because we're taking off it's 1.414 and we're taking that part away.
For
We're
the
taking
square
the
root of
1.
2.
So, and we can just keep doing this.
Okay, but what do I get when I now have the square root of 2 plus 1? What do I get for the integer part?
We get it's 2 plus 0.414.
Okay, very good. So this now equals 1 plus 1 over, I can get rid of this 1 on the bottom, right?
Yeah.
2 plus, and now I have the square root of 2 minus 1 again, right?
2 plus square root of 2.
Because I have that same 0.414.
Cool.
Yeah.
And we already said that was the square root of 2 minus 1. Or I could say that 2 minus 1 leaves me with the square root of 2 plus 1.
Interesting.
But what happens when I do my flip and rat and then split again with the square root of 2 minus 1?
Well,
You're going to get this. You're going to get what we got here again.
Right. We're going to get what we got again. So now I get 1 plus 1 over 2 plus 1 over 2 plus the square root of 2 minus 1. What happens on the next stage?
The exact same thing
you
happens.
keep doing it.
You keep doing it. So what is the continued fraction for the square root of 2?
1 plus 1 over 2 plus 1 over 2 plus 1 over, etc.
Cool.
How cool is that?
I don't think we can put a bar over continued fractions.
No, I think we just use these dot dot dots. But there actually might be some notation that talks about how to deal with this repeating part. But that's just our split, flip, and rat. And here's one of the neat things. One of the things you probably hear sometimes about irrational numbers like the square root of 2 is they have decimal representations that don't go on forever. Or, that do go on forever and don't repeat.
Interesting.
Right? Yeah. But here's a very simple repeating pattern that goes on forever for the square root of 2. It just involves a continued fraction.
Cool.
Pretty cool, right?
Yeah.
Yeah.
All right. Ready for pi?
Yeah.
Yeah.
I mean, are you ready for the continued fraction for pi?
Yeah.